This is Radio TV Phono Nut, and I hope everybody had a nice Thanksgiving. And while everybody else was going crazy at Chinese Mega Mart on Black Friday, I was procuring more vintage electronics. Me personally, I like nice quality stuff, not Chinese throwaway crap. But anyway, what we have here today is a Silvertone wireless record player. You may be asking, what is a wireless record player? Well, it's actually a 78 RPM record player that contains a built-in low-powered AM transmitter, and its purpose is to transmit the audio from the record that's playing on the turntable to a nearby AM radio. The thought behind that is to add phonograph capabilities to radios that might not already have a phono input jack on them. I don't know exactly how old this is, but I'm guessing probably early 1940s. These were very popular from the late 30s to early 40s and immediately after World War II ended. You'll notice it has the standard crystal pickup cartridge that tracks at about 200 pounds. No counterbalance spring on the tone arm, but there's a place for one, so this will be getting a more modern ceramic pickup cartridge and a counterbalance spring added, so it will track lighter. Take note of our UL approved power plug here. This cord will have to be replaced. And you'll notice it's a 3-wire cord, not because it's a grounded power cord, but they're using one of the wires for the transmitting antenna. We can just use a standard separate piece of wire for that. Actually, I think Silvertone or Sears offered a record player, several different types of record players using the same case style. The first was obviously this type, the wireless record player. Then they had another one that had a cable that plugged into the phono jack on radios that were so equipped. And then I believe there was one more that had a built-in amplifier and speaker. They were nice enough to give us a schematic. It's just a little 2-tube series string job, 35Z5 rectifier and a 35L6, which would normally be used as an audio output tube in a radio or a conventional record player, but in this case they're using it as the oscillator and modulator tube. The oscillator section is what creates the carrier frequency that's transmitted, and the modulator function, if you will, imposes the modulation, the audio from the record onto the carrier frequency. Here's the inside, really not much to it, and I don't really anticipate any problems in restoring this. The only issue might be if the oscillator coil is open, but really can't think of anything else in this thing that could be bad that would keep this from being a routine restoration. Of course, I shouldn't say that, because in the wonderful world of electronics, anything is possible. Here's the chassis exposed for servicing, and I just checked the oscillator coil. Both windings read good, so as far as I'm concerned, we're good to go on the restoration. I'll replace all of these paper capacitors, get rid of this electrolytic, check the resistors, change any that are out of tolerance, take the drive mechanism apart, clean it and re-lubricate it, and put a new cartridge in it, and hopefully we'll be transmitting records at that point. So hopefully the next time you see this amp, it'll have a makeover, or not amp, transmitter I should say. So I will say this was a very cramped up chassis to work on, and 3 hours later I just about have everything where it needs to be. As much as possible, I try to disconnect everything from the actual terminal that the part was associated with and reconnect to that terminal. I tried not to do any J-hooking, but there's one resistor down in here where I did that too, because it was so cramped up and so much other stuff in the way. I decided not to take a chance on my soldering iron slipping and possibly hitting this coil and damaging it. or possibly breaking a tube socket pin off, so I cheated a little bit there. And right here on this coil, this terminal on the oscillator coil, I pretty much have a rule with coils that I don't bend and tug and push and pull and all that on coil terminals, because they can break off very easily, and you can also break the little winding going to the terminal from the coil, so we don't want to do that. So I just whatever needed to be soldered here, I cut the lead off as close as possible, wrapped the wire around it, and soldered it. Here's our replacement filter capacitor soldered to a terminal strip that I put on the chassis. The old capacitor is out of circuit, but it's still there for looks. I just tied the negative terminals of our new filter capacitor to the negative terminal on the old capacitor, and of course disconnected the positive terminals on the old capacitor. Here's something else I'll call to your attention. Here's something here that if you just glance at it, it looks like an ordinary piece of wire. However, it's not a piece of wire. This is actually a resistor, a 1000 ohm 1 watt resistor, and you can tell by at each end you have end caps here with a wire coming out of it soldered to the respective terminals. I believe they called these a flex ohm. I believe that was the correct term for them back in the day. Well, anyway, this one's still good, so I'm leaving it alone. The original 10K ohm resistor across the two filter capacitors, old dog bone resistor, was still good, but in the process of trying to disconnect it from the old can, I ended up breaking off one of the leads, so no biggie. 10K ohm resistors are plentiful and cheap. This resistor here, a 33K ohm resistor, was reading well over 1 meg ohm, so that had to go. And here's its location on the schematic. It's in the oscillator, and on the oscillator and modulator tubes. So yeah, that one going way up in value could have caused some issues. And then this R3, which connects to our audio input to the tube, it's our grid bias resistor. It's supposed to be 680K. It's gone up about 100K. Probably wouldn't have caused really any big problems, but I went ahead and replaced it anyway. So that about does it. All I have left to do is connect the other end of the power cord to our on-off switch, and then we should be able to put it back together and give it a try. And yes, I replaced all of the original sleeving that was on the old power cord. I slid it over the new power cord. I think the purpose for this stuff is for heat protection in case the wire accidentally touches one of the hot tubes, especially the ballast tube. It'll kind of protect the insulation from melting, so I wanted to go ahead and put all that back in place. Okay, we're in test mode here, and it looks like we're making progress. We're getting some RF output by just simply placing the antenna lead up close to my oscilloscope probe. Remove the antenna lead, and the signal goes away, so at least we're producing a carrier. Now all we need to do is redo the drive mechanism and put a cartridge in here that's good, and hopefully we'll be able to broadcast some music. Okay, I've cleaned the cabinet up a little bit. Need to polish it. Doesn't look really good then. I've cleaned and lubricated the drive mechanism. Idler wheel needs to be rebuilt, but surprisingly it's fairly quiet considering how dried out the wheel is. I replaced the original crystal cartridge with a static 89T cartridge. What's in here now is something out of an old school record player that I scrapped out. Don't know how good it is, but eventually I'll order the little green 78 only cartridge and slide up in there. Had to install a counterbalance spring on the rear of the tone arm to get the tracking weight down to about 11 grams. They were nice enough to give us the holes for such a spring, but no spring. Now let's try it out and see if it works.
confess.
Well, it works, but our idler wheel's slipping a little bit.
I wish you'd reveal to me the way that you feel.
And it's not as loud as what it would have been originally because we're only using a 1-volt cartridge versus the 3-volt cartridge that was originally in here. I might have to add a little preamp stage to compensate for that. Okay, there we go. I cleaned the drive surfaces a little bit better. Must have got a little drop of lubricant on them. Now it's running better. So yeah, boys and girls, wireless Bluetooth and all that is nothing new. We had it back in the 30s and 40s too. Just a few things to note on these types of units. The transmission antenna, which is this long piece of wire here, and can affect your transmission frequency based on the length of the wire and even the position of the wire. If you need to change your transmission frequency, most of these have a trimmer that you can adjust. In this particular model, you pop this little plug out right here, and there's a trimmer capacitor in there that you can adjust to determine your transmission frequency. Also, these are only good for a few feet. You know, their purpose was to be placed near a radio, not to transmit to the neighborhood, but they do pretty good for what they are. And like I said before, this might do a little better if it had a high output 3-volt crystal cartridge in it. Of course, I could get around that by adding a preamp to this, which I may or may not do later on.
Some enchanted evening.
Okay, we'll end this with a little Bing Crosby for your listening pleasure. Hope you got something out of all of this, and more to come later.
Across a crowded room, and somehow you know